So something is a contradiction if the truth table is false, no matter what truth values is assigned to P and Q. Something is a tautology if no matter what values you assign to P and Q, you get something that's true all the time. So we need to make a truth table here. Easiest way for me to do that with my computer is probably typing it. We got P, we got Q, so we have lowercase. We got not P going on, and we got not Q going on. And then this is biconditional. So we're going to need to know what P and not P is. We're going to need to know what Q and not Q is. You might be able to fill those out if you've had a lot of practice with this. And then we need to check both conditions. We need P and not Q implies Q and not Q here. Oh, sorry, P and not P here. That needs to hold. And then the reverse, if you switch the order, Q and not Q needs to imply P and not P. So that's how we can handle that double arrow, okay? Okay, the truth table will look a little prettier once we get some values. So the way we do the truth table is we usually start by filling out these. We got true, true, false, false, true, true, false, false. And then not P is just the negation of P, so it's the opposite. Not Q, same thing. Whoops. It's the negation. If I can type, there we go. False, false. Oh my gosh, I messed this up. I'm sorry, this is supposed to alternate. So Q is supposed to be true, false, true, false. So true, this would be true. Now we got them alternating just like they're supposed to be. Okay. P and not P, they both have to be true. That's not going to happen anywhere, right? When P is true, not P is false. So we can just fill this up with the F's. Same thing over here, where Q is going to be true, and not Q is going to be false. So that's a quick column to fill out. In order to fill out this column, the conditional, let's see, not P implies not, look, not P and not, so P and not P, this part right here is false throughout. So that means this whole thing is going to be true because of what we studied with conditionals, right? If the first part of the conditional is false, then the whole conditional is true. So that's a nice, quick, easy column to fill out. And then it's actually going to be the same thing with the other one. Q and not Q, that whole column is false, so the conditional automatically evaluates to be true because this part always starts false. And so that means the biconditional holds, and it's true in all those aspects of the biconditional. So we circle this option down here. Always, always true. This always evaluates to be true. I will drive the car. Let's call that P. I will not go shopping, so let's say it's not Q. So we got to list all the options. We could have true, true, false, false. Oops, that's a bad F. We got true, false, true, false. And then not Q is just the negation of column Q, so we got false, true, false, true. And then the statement says, I will drive the car and I will not go shopping. So we got to find out where P and not Q are both true. So we got true, false. They're not both true there. True, true. They're both true there. False, false. They're not both true. False, true. They're not both true. So this isn't a contradiction. It's not an implication, not a tautology. It's not a contradiction because it's not all false. It's not this because they're not all true, and we don't have any sort of arrows going on for some sort of implication, so this is none of the above. Let's let P be the event that Bill likes chocolate. Then him not liking chocolate can have this symbol, right? So this is saying Bill likes chocolate or he doesn't like chocolate. Now think about the truth value there. And if P is true, then not P is false. Then P or not P is always going to be true. It's going to be one or the other. So this is a tautology.